Hi there, I'm Adam from CatBorg Studio.
In this episode, we'll continue with enemy AI by adding its fighting state. The video is split into several sections. We'll start by working with ZombieControler fight state, then proceed to zombie and player combat script, attack cooldown, damage indicator, and optimization techniques. Feel free to use timestamps as needed to navigate through the content. We're beginning with developing fighting state in our zombie controller. Let's start by declaring new variable. We'll add serialized field attribute to it, so we'll be able to inspect it during play mode. It will be type of bool m_player close enough to attack, and set initial value to false. Now, during each frame we'll reset bool value to false. Here we'll determine bool value by writing m_player close enough to attack equals m_distance is lower than m_navmeshAgent dot stopping distance. Now, if m_player close enough to attack equals true, we could set m_current state to zombie state dot fighting. Let's jump to our switch statement. When m_current state equals zombie state dot fighting, we could add some code in order to check that my state machine logic working as I expected. Simple debug.log will do. Now, each frame when conditions are met, will receive console message. Let's get back to Unity, enter play mode, and check out how our zombie is doing. As we can see, exactly as expected, console spamming huge amount of attack player messages. Now, as we will add some new combat logic to our player and zombie, we will need to add some more code to handle it. And because our zombie controller script is getting big, we'll introduce two new script classes into our project. Go to scripts folder and add new script. Change name for player combat, then add it to our player game object. Again, add new script, change name for zombie combat, and add it to our zombie game object. Now, inside our zombie controller script, we'll declare a new variable, type of zombie combat, m_zombie combat. So during start void, we could set m_zombie combat value to get component type of zombie combat. And finally, during zombie state dot fighting, we could call m_zombie combat dot attack player. As we can see, we're getting some error due to the fact that this void not exists yet. Let's generate it. Now, while holding Ctrl key, left click to inspect it. Let's start by removing not needed code and changing from internal to public. inside this attack player void, we'll do some harm to player, and in order to do it, we'll need to get reference to player combat. We'll acquire it through enable void. This enable void will have input parameter, type of transform, and name underscore player transform. Now, let's declare new variable, type of player combat, name it m underscore player combat. So inside enable void, set m underscore player combat equal underscore player transform dot get component type of player combat. Before we forget, let's get back to ZombieControler script for a second, and after grabbing reference to zombie combat, let's add m underscore zombie combat dot enable and feed it with m underscore player. So, as we are now able to access m underscore player combat, we could call m underscore player combat dot damage. As we can see, we get some error due to the fact that void don't exist yet. So let's generate damage void and inspect it. As always, let's start by removing not needed code and changing void from internal to public. Now we need to declare some variable. We'll add serialized field attribute to it. It will be type of integer and name m underscore health. So each time when damage void will be called, let's remove 1 point from our player m underscore health. Same code could be written like this. Then if m underscore health is lower or equal 0, we could call void die. We had error, so we need to generate it. Inside our new generated die void, we'll do some dying things later. Before we continue, we'll add some code which will allow to terminate further code execution if player die. So let's declare bool m underscore is dead and set its initial value to false. Now when die void will be called, m underscore is dead equals true. And finally, when damage void is called, in the first line we'll add if m underscore is dead equals true, then return. So we'll terminate further code execution here. Although code looks fine, let's add input parameter to damage void. Will be integer underscore damage. So we'll be able to push amount of damage which hurts player. Let's change code here. So m underscore health will be decreased each time with amount of underscore damage. Same code could be written like this. Now, as we get back to zombie combat, let's declare a new variable with serialized field attribute will be private integer m underscore damage. So now from level of inspector, we'll have option for setting up amount of damage zombie will deal each time when attack player. We just need set m underscore damage as the input parameter during damage void call. Let's get back to Unity editor, set amount of m_health in player combat for 100 and value of m_damage for 1 in zombie combat. Now, as we enter play mode and zombie manage to attack our player, we can see player health hitting 0 crazy fast. And that is some interesting problem. That's due to the fact that update void is called with each frame, so our damage void is called multiple times during each second on our player combat. We could either set player health for something like 10,000, which will result in some weird new issues, or we could implement some sort of attack cooldown to handle our small issue. Believe second solution will be better for our game, so let's get back to zombie combat script. Now, add enumerator attack cooldown, inside write yield return new wait for seconds real time. We'll need to feed it with some time amount, so let's declare new variable. We'll add serialized field attribute to it. It will be float m_cooldown. And now let's add this m_cooldown as amount of timecode will suspend further execution. Now we'll declare some new bool, name m_attack is ready, and set initial value to true. So now inside our enumerator at beginning we set this m_attack is ready to false, and after expected code suspension we'll set its value to true. Now at our attack player void, let's add simple check if m_attack is ready equals false. Then we abort further code execution by calling return. Finally, each call of attack player void needs to end with starting our enumerator. So let's write start coroutine and feed it with attack cooldown. As we get back to Unity editor, thanks to serialized field attribute, our private variables are exposed. Set damage for 10 and cooldown for 2. Enter the play mode and check out how our attack cooldown is working. Perfect. As expected, amount of player health is sliced according to cooldown time delay. Although, when player health reaching 0, we are still able to move, due to the fact that we don't implement anything in die void yet. Now, we'll not only remove control over player game object from end user, but due to the fact that we have already implemented game manager, we could simply introduce new way game reach its end. So let's go to game manager and add new public void. Name it player died. We'll declare new serialized field bool m_player die and set initial value to false. Now, when our new public void player died is called, we'll simply set m_player die value to true. Finally, to make it work inside enumerator main part of game, we need to add new while check condition here. So, as long as player not win and player not die, further code execution will be suspended. Now, we need to call our new added public player die void from player controller inside die void here. But we don't have reference to game manager. Lazy way to do it looks like this, but this bad habit will cost our game lots of performance. So now let's do this in right way. We'll need to call m_player controller dot player die. As we can see, we're missing m_player controller variable. So let's start by creating public enable void with input parameter type of player controller and name it _player controller. Now declare variable type of player controller m_player controller, and inside enable void we could simply set m_player controller equals _player controller. Let's jump for a second to player controller script. We'll need to declare variable type of player combat m_player combat. Now we grab and store reference to player combat component attached to this game object. So we could call m_player combat dot enable and feed it with this as input value. So now, as we get back to player combat, we could see error indicating missing player die void. Let's generate and inspect it. As always, change from internal to public, remove not needed code, and write m_game manager dot player die. Again, we could see that we don't have this type variable yet, so let's declare it. We'll add serialized field attribute to it, so we'll be able to assign reference to it in the inspector. Now, as we get back to Unity editor, let's assign game manager reference to our player controller, enter play mode, and allow zombie to attack our player. As we can see, as player health reached 0, we getting end of game message in console. Moreover, as expected, control from end user is removed. Now, let's add some receiving damage indicator, which will change player mesh renderer material each time when player receives some damage. To make this happen, let's get back to our player combat script and introduce new enumerator. We'll call it damage indicator. In this part, just for teaching purposes, we'll write very performance costly solution. In further part, we'll show you how to make it better. So let's start with this terrible version firstly. Each time when damage void will be called, we'll start coroutine here. Now let's frame our work. We need to change material for damage version, then we need to suspend further code execution for some time, and then we'll change material for original version. Finally, during enable void, we'll grab original material reference. So, in order to suspend code execution, we'll write yield return, new, wait for seconds real time, and feed it with .15. Now we need to declare some variables. We'll need serialized field, material, m_damage material, and material, m_original material. So during enable void, we could set our m_original material to get component type of mesh renderer dot materials 0. Changing material is a little bit tricky because it can't be done directly in mesh renderer. We need to declare array of materials _materials and set its value to get component type of mesh renderer dot materials. Then we changing first element of _materials to m_damage material, and finally we setting up get component type of mesh renderer dot materials to _materials. After code suspension, we'll do similar material change for original material. As we get back to Unity editor, we need to assign our damage material reference. We'll select enemy color, so each time player is damaged, will look like he's changing to zombie for a second. Now, as we enter play mode and zombie will manage to attack player, we could see our first damage indicator. Although working as expected, code is terrible, so let's fix it. We'll start by declaring new variable type of mesh renderer, m_mesh renderer. So we'll use get component only once. Let's grab reference to mesh renderer during enable void. Now we could replace all places when we use get component type of mesh renderer with our m_mesh renderer. Now let's declare array of material and name it m_materials. We'll assign it value during enable void. So now in order to get original material, we could grab first element of m_materials. Finally, we don't need to declare new array each time now, so we'll only change first element in array and assign our m_materials to our m_mesh renderer. Now we could remove all comments. Believe code performance is better now. Let's get back to Unity editor and check out is our damage indicator still working. Perfect.
That's all in this episode. Let me know how do you like this content in the comments below, and see you in the next one.